Welcome back, everyone. In these next two examples, which I know I didn't label them, but it should be example 8 and 9. In these two examples, I'm going to teach you how to graph parabola transformations by hand. Holy hot dog, right? I know. Guys, so what we're going to do, we're actually going to be graphing these by hand, and I'm going to show you what each graph will look like as it undergoes each transformation. And at the very end, we're going to get to our final graph, which would be the equation that I have for you. Okay, so basically these two equations will be our final graph, and we're going to do one transformation at a time to get there. Now, like we talked about earlier in this section, whenever we start graphing transformations, you're always going to start from something called the parent function, which hopefully this looks familiar. You guys graph this. Okay, so our start graph is the parent function, which the parent function is the most basic form of our quadratic equation. If you see, nothing is added, subtracted, or multiplied to the x squared. It's just a plain old quadratic. Okay, so the most simplest form of the equation without the a, h, and k would be your parent function. And gradually we're going to add on the a, h, and k to get to our new graph. Okay, now the parent function is y, or f of x, equals x squared. Okay, so basically remember when we graph the parent function, technically you don't have to use these values, but you're really not going to get a complete looking graph if you don't use these values, which the important thing is it's good to use some negatives, 0, and some positives, which I picked the smallest negatives and positives, which the smaller number that you have, the easier it will be for you to graph. So ultimately, in my opinion, these values are always going to be the easiest ones for you, but technically you don't have to use them. But anyway, so all I did was I squared the -2, -1, 0, 1, and 2. So me personally, I'm going to be using the -2, -1, 0, 1, and 2 whenever I do my parent function. And all you do is square them, like -2 squared, -2 times -2 is positive 4. -1 squared, -1 times -1 is positive 1. 0 squared, 0 times 0 is 0. 1 and 2 squared, 1 times 1 is 1. And 2 times 2 is 4. Guys, so every single time we graph transformations, okay, we will always start from the parent function. Every single time. So this graph that you see right here will always be the very first graph that we start with. So you should always have this table, you should always have this graph. This is always step 1. Okay? And then after that, depending on what the a, h, and k values are, your graph will move around in different directions. It's about to get exciting, so get pumped up, you guys. Okay, so let's get going on this graph. Guys, so we have our equation y equals -2 times x minus 3 quantity squared plus 5. Okay, so each time I'm going to do one different transformation at a time, and at the very end, we should get to our final graph, which is ultimately what this equation's graph looks like, which is pretty cool. Okay, so again, like I told you guys, we always start with the parent function every single time. Okay, so we're going to start with y equals x squared. Okay, and these will always be the values. So this step should always be the same every single time. Okay, which I already have the table made. I'm going to go ahead and plot those points. If it helps you to see these as coordinates, you can write coordinates beside them if that helps you. Okay, so this would be the coordinate like -2, 4. This is my x, and that's my y. So -2, 4. We have the coordinate -1, 1. 0, 0, 1, 1, and 2, 4. All right, I'm going to plot these bad boys right here. So -2, 4, 1, 2, 3, 4. Okay. Then we have the point, -1, 1, 0, 0, 1, 1, and 2, 4. Look at that beautiful U-shaped graph, which we call a parabola, and I totally missed that point. Sorry, guys. Try not to miss your point on your graph. Anyway, so this is what we're always going to start with. Okay? Now, after the parent function, it is very important that the next transformation that we tackle is always the a value. Now, it's not wrong if you don't do the a value first, but I'm going to tell you, if you wait to do the a value to the end, it's going to get a lot more complicated. So I like to just go ahead and deal with the a value, and then after that, it doesn't matter if you do the h or k value next. Okay, so these two, the order doesn't matter. Okay, but the a value is much easier to do if it's done first. So we're going to tackle the a value first. So looking at our standard form of transformations, which one of these values is the a? The -2, the -3, or the +5? Well, the a is the number right in front of the parenthesis. It's the very first thing you see. Okay, so the very first thing I spot after the equal sign and before my parenthesis is the -2. Okay, so what I'm going to do, I'm just going to add on one transformation at a time to my equation, and we're going to build up the equation until we get to this one. Okay, so currently I have y equals the a is -2, so -2, and I'm adding it to this equation. So I'm just going to bring on down the x squared. So the only thing I've added to my equation is the -2, which is our a value. Okay. So now I have a chart to help you guys graph what the a value equation will look like. This equation, -2 times x squared. Okay, but before we do that, remember you guys, we already should know what's going to happen based on what our transformations tell us. So remember, you guys are like math magicians. You can already predict what the graph will do before we even graph it. So I already know how my parent function will move based on this value. Okay, so first of all, since a is negative, do you guys remember what happens to your graph when the a value is negative? Of course you do. When a is negative, the graph will, oh, sorry guys, the graph will flip upside down, okay, which is called reflecting over the x-axis. So since a is negative, okay, the graph will reflect over the x-axis, reflect over x-axis, and that's because a is negative. So I already know my graph should flip upside down if I do it right. Okay, now, if a is anything other than 1, it's also either going to vertically stretch or compress. Okay, so when you have a negative a value that is anything other than 1, it's going to be a combo. It's going to do two things. Okay, so if this was just -1x squared, it would just reflect. Okay, but since it's a -2, if it's anything other than 1 and it's negative, it will do two things, which is really cool. The more transformations, the better, right? I agree. Okay, so when a is not a fraction, or if you ignore the negative, if this is greater than 1, do you guys remember what the graph will do? It will vertically stretch out. It's going to stretch out, which will cause the graph to become more narrow. So the graph will become more narrow, which is called a vertical stretch. So it's going to vertically stretch by a factor of 2. Okay, so that means the length will be 2 times the length that originally was, which means the graph will become more narrow, and I would appreciate it if you would stop freezing. Thank you. So the graph will be twice the length, which will force the graph to become more narrow because it's going to be increasing at a much faster rate. Okay, so I already know the graph should flip upside down and get a little skinnier if I did it right. So let's see. Okay, so when you guys are graphing the a value, this is the only transformation where I'm going to require you to, well, I'm not going to require you, but it will help you to make a table. Okay, the h and the k value, you won't have to make a table because we can do it on the graph. But the a, it's a little bit more complicated if you do it on the graph. Okay, so if you notice, these values are the same values as the parent function. All I did, you guys, I literally copied down the parent function, but we are going to do one additional step to our parent function table. Okay, so go ahead and copy down these points, make your table. I left a little space here because we're going to be multiplying something to our y values, okay? So go ahead and copy this down. Okay, so now that we have the equation y equals -2x squared, okay, so these points are the points for y equals x squared. Now we have the equation -2 times x squared. Okay, so what we're going to do, we're going to take all of our original y's from the x squared graph and multiply them by a -2. Okay, so all you have to do when you're graphing the a value graph is take your parent function points, okay, leave the x's alone. If you see, my x's are the same. And what we're going to do, we're going to multiply all the y's by the a, which in this case, a is -2. Okay, so all you got to do for the a value is multiply the y values in your parent function by a. Alright, so this will give me 4 times -2 is -8. 1 times negative 2 is negative 2. 0 times negative 2 is 0. 1 times negative 2 is negative 2. And 4 times negative 2 is negative 8. Alright, so now I have the points negative 2, negative 8, negative 1, negative 2, 0, 0, 1, negative 2, and 2, negative 8. Okay, so I just took my parent function and I multiplied all the y's in the parent function by a. And if I did it right, my graph should flip upside down and get more narrow because it's going to vertically stretch. Alright, so I'm going to plot these points and see what happens. Alright, so I have the point negative 2, negative 8. So negative 2, then 1, 2, 3, 4, 5, 6, 7, 8. Look at that. I planned it out, so. So negative 2, negative 8. Then I have the point negative 1, negative 2. 0, 0, so that stayed where it was. 1, negative 2, and 2, negative 8. Look at that, you guys. Heavenly hamburger, you guys. Do you guys see it flipped upside down? And it's kind of hard to tell, but the graph is a little bit more narrow, which, man, I have something going on about missing 1 point. What's going on? Try to connect all your points. Man, I'm not having a good day apparently. But anyway, so if you guys see, the graph flipped upside down and it got more narrow. Okay, so we've got one value done. Okay, now we got to tackle the next two. Now, the next two values, it doesn't matter if you do the h or k next. Okay, these two, the order does not matter. If you do the k first, then the h, or the h, then the k, you will end up with the same graph at the very end. Now, your steps on your graph might look a little different, but ultimately your end graph will be the same. Okay, so me personally, I just like to tackle the h next. Okay, you don't have to do the h next, but that's just a personal thing on me. Okay, so which value is going to be the h value in my equation? Is it the minus 3 or the plus 5? Which one is the h? The h is the value that's added or subtracted to the x. Well, that would be the minus 3. So what I'm going to do, you guys, I'm going to take my most recent equation, which is this one, and just add on the h value. Okay, so I'm going to say y equals negative 2. Technically it's x squared, but now x is going to have something added or subtracted to it because I have an h now. So this is going to be minus 3. Okay, so if you see, I'm kind of adding one part of my equation at a time. So we're tackling the h now. Yes. Okay. So what we're going to do, you guys, first of all, we're math magicians, right? We can already predict what's going to happen to the graph based on the h value. So don't forget, you guys, when you have the h value, you must think the opposite. You have to think the opposite. Okay, so if we're going minus 3, which way does the graph go if it's x minus 3 for the h? Do you guys remember? Absolutely, you guys remember. Okay, so remember, we think the opposite. So if it's x minus 3, okay, the h value will go left or right. So when we think the opposite, the minus 3 tells us we're going to go to the right. Okay, so we're going to go, the graph moves right 3 spaces. Alright, now, I am not going to make a table for the h value. Technically, you can, but in my opinion, the h and k are really easy to do if you just move your points on the graph. Okay, so what we're going to do, we're going to start from the most recent graph that I have on my corner grid. What was the graph that I graphed most recently, which is my a value graph? Well, that would be the pink graph. So, what I'm going to do, I'm going to take all the points on my pink graph and move them to the right 3 spaces. Okay, so I'm going to start here. I'm going to count 3 to the right. So, 1, 2, 3. Let me just double check. That's up to 2. So, 1, 2, 3. So, yeah, about there. If you have graph paper, your graph will be much more accurate. So, just saying. Alright, so this one's going to go 1, 2, 3. I'm going to count from this point and go 1, 2, 3. I'm going to count from this point and go 1, 2, 3. And I'm going to count from this point and go 1, 2, 3. Look at that, you guys. The pink graph has moved 3 to the right. Look at that. And again, I'm missing 1 point. Get it together, Miss Long. Okay. So now that we've tackled the h value, the only other value we have left is the k value, which don't forget the k value is whatever is added or subtracted to the end. Okay, so I'm going to start from my most recent equation, which is this one, and I'm going to add on the k value. So I'm going to rewrite what I have here. And I'm going to simply add the k value to the end, which will ultimately be the equation that I'm trying to get graphed, which is pretty awesome. So that means we're getting close to the end, which actually that's kind of sad. I hate when we finish a problem. Anyway, so the k value is a positive 5. Do you guys remember which way the k value goes? Well, the k, remember, so h, you think horizontal, so going left or right. K, you think kangaroo, which goes up and down, right? So the k value is going to go up and down. Since k is a positive 5, remember with the k value, you don't think the opposite. Don't think the opposite. So it's positive 5. If you're going up or down, the positive direction is to go up. Okay, so this one is going to go up. Sorry, 5, not 2. Good golly, Miss Long. Up 5 spaces. Sorry. 5 spaces. Okay, so what I'm going to do, this is the last step, you guys. Actually, technically, there's 2 more steps. Anyway, so I'm going to go to my most recent graph. Okay, which was the graph that I most recently put on my coordinate grid? Well, that would be the h-value graph. Which one of these is the h-value graph? That would be the green graph. So I'm going to start from the green graph. I'm not going to make a chart this time. What I'm going to do is I'm going to take my points on my green graph and count up 5 spaces, and that will give me my final graph. That will be the equation that we're trying to graph all along. So I'll start from here. I'll count up 5. So we're at 1, let's see here, 1, 2, 3, 4. Alright, so we're right here, so I'm going to count up 5. So 1, 2, 3, 4, 5. Again, this will be a lot more accurate if you have graph paper. So I'm going to start from this point and count up 5. So 1, 2, 3, 4, 5. Going to count up 5 from here. 1, 2, 3, 4, 5. Count up 5. So 1, 2, 3, 4, 5. And then from here, I'm going to count up 5. So 1, 2, 3, 4, 5. Look at that. So guess what, you guys? The purple graph is ultimately the graph of the equation we were trying to graph all along, and each transformation helped us to get there. So this is your final graph, the lovely purple graph. So there you go, you guys. That's how you graph transformations. Don't they look cool? I know, it's like a work of art. It's so pretty. You could like frame that and put that on your wall. Okay, so ultimately the last step, don't forget the most important step. So we've tackled all of our AH and K values. The last and most important step is to always name your graph. Your graph deserves a name. So you must name your graph. I'm going to name my graph Darla. It looks like a Darla graph. Well, there you go, you guys. So example 9 is going to be pretty much the same thing. I already have it set up and ready to go. So if you want to try example 9 on your own, I say go for it. Otherwise, you can do it with me. Well, nice job, you guys. You always do such nice work. I'm so proud of you.